All right, so this is section 2.2, which is quadratic functions and equations. I'm going to show you how to get a quadratic function into vertex form, which is our preferred form of these lines, and then from that form, how to identify the x and y intercepts, the vertex, the axis of symmetry, a whole bunch of neat stuff that's going to help us to graph quadratic functions and equations. Okay, so first of all, I'm just going to review. We've done linear functions. When we do linear functions, remember they look something like y equals mx plus b, and these make a straight line when graphed. Okay, remember we always wanted those in slope-intercept form, which is our y equals mx plus b. When we graph them, it made a straight line. Now with quadratic functions, this looks something more like y is equal to ax squared plus bx plus c. Okay, and when we graph these, they make the shape of a parabola. Okay, make the shape of a parabola when graphed. Okay, and I'm going to go ahead and put here, since it's under functions, okay, we may see these written as f of x is equal to ax squared plus bx plus c. Either way, y is the same as f of x. We just use y when it's written as an equation. If it's specifically a function or written in function notation, then we use f of x. Okay, and I will go ahead and put a little note here that these are easiest, I said easier, easiest, the easiest to graph when in vertex form. Okay, anytime we graph these, we want these in vertex form, which we'll go over that here in just a minute. I want to go ahead and show you what the graph looks like. Okay, the graph of a quadratic function. Now look right above. I have a quadratic function written in standard form. It's ax squared plus bx plus c. Notice your a is your leading coefficient, or the number part of your x squared term. All right, so the a is your leading coefficient, and that tells us a lot. Okay, if a is greater than 0, meaning it's a positive number, then we have a parabola that opens up. Okay, it looks something like this. So I'm going to put over here, parabola opens up. Okay, if our leading coefficient is negative or less than 0, then we end up with a parabola that opens down. Okay, I'm just going to put here, parabola opens down. Okay, so right away we can tell whether it should be pointing up or down just by looking at that leading coefficient. Okay, some other things we want to know about our parabola is the vertex. Okay, the vertex of our parabola, excuse me, is the highest. Whoops. Let me write that where we can actually see what it says. The highest or lowest point on the parabola. Okay, it's the highest point if the parabola is facing down, like this one to the right, and it's the lowest point if our parabola is opening upward, like this one on the left. Okay, so it's either the maximum point or the minimum point, okay, depending on which way your parabola is opening. Whenever we went over this section of Math 118, if you're in Math 118, I referred to this as the center. Okay, the center of our parabola. And we always write it, I'm just going to go ahead and say here, it's denoted HK. Just like the center of our circles, we used H and K. Same thing here for our vertex, which is the center of our parabola. Okay. The other things we'd like to know is our axis of symmetry. Okay. Our axis of symmetry is the line about which the parabola is cut into 2 equal halves. Okay, and some people say the line about which the parabola is reflected about itself or something of that sort. Really all we're looking for is if I take any parabola and I draw a line down the absolute middle of it, then this side of the parabola looks exactly like this side of the parabola. If I were to fold it, it would look exactly the same each side. So what I want to know is what is that line that cuts the parabola perfectly in half so that the right side looks like the left side. Okay, and that always happens to be the line x equals h. The line x equals h, where remember h is the x value of our vertex. Because notice if I go up here, I wrote these right on the x-axis, but hopefully you can see my blue line. The line that cuts this right down the middle is going to be the x value that goes through that parabola. So here my axis of symmetry would be x equals 0 for both of these. Anytime I'm looking for the axis of symmetry, it's always going to be x equals whatever that x value is of the vertex, because it has to go through that vertex point. Okay. The next thing we're looking at is the maximum or minimum value. Now this goes back to the vertex again, but when we ask for the maximum or minimum value, we're looking for the y value. What's the highest y value or what's the lowest y value? And depending on if it's facing up or down, that's what makes it a max or a min. Okay, so if it's a maximum value, this is for a downward facing parabola. Okay, and this is the y value of the vertex. Okay, so this would be y is equal to k. Same thing on the minimum value. Okay, this is for an upward facing. I say upward facing. You can say upward opening, whatever makes sense. Upward facing parabola. And again, this is just the y value of the vertex. Y equals k. So notice you can't have both a max and a min. You either have a maximum value or you have a minimum value, depending on what your parabola looks like. The other thing I want to point out is once you know your vertex, once you know that vertex point, your x value is always going to be your axis of symmetry, and your y value is always going to be your maximum or your minimum. So you don't really have to think through it, and there's no way to solve. It's just once you know that vertex, you should know those two things right off the bat. Okay, so let me go ahead and tell you what vertex form is, because notice when they're written up here in our standard form for a quadratic function, ax squared plus bx plus c, that doesn't tell us anything about the vertex. That just shows us the equation, right, or the function. So what we want to do is we want to rewrite that function in vertex form. The reason we like vertex form is because when it's written in vertex form, we can clearly see the vertex. Okay, so let's go ahead and look. Vertex form looks like f of x is equal to a times the quantity x minus h squared plus k. Okay. And I'm going to put over here, or y equals a times x minus h squared plus k. It can be written as a function or as just a regular equation. Okay, and I'm going to put down here where a is our leading coefficient, okay, and the point hk is our vertex. Okay. So notice when it's written in the function, just like with circles here, I'm going to do a little arrow, just like with circles here, we're doing x minus h, but when we get our vertex point, it's a positive h. Okay. The reason is, if you're in Math 118, remember we went over how to find the absolute center point, or that top, the vertex point, when we were graphing. And remember, the point that always gave us that center point is the value for x that makes inside this squared quantity 0. So here, what would I have to plug in for x to make this 0? It would have to be a positive h. So that's why in our vertex point, it's actually a positive h rather than a negative. Okay, if we had a plus here, then it would be a negative in our point. So whatever our h value is in our equation, we change the sign when we write it as our point. Okay. Now notice k is not coming from a squared quantity. K is just a constant that we're adding off to the right. So k I don't have to worry about changing the sign of. Whatever k is, it stays the same in our vertex point. All right, so let's go ahead and look at how to identify the vertex, the axis of symmetry, the maximum, the minimum, and intercepts again. Okay. On this next page, this one's already graphed for us. I don't have to worry about vertex form or anything. They just want me to identify all the important parts. So notice my vertex, remember, is the highest or lowest center point of my parabola, which here is this point. So I get the ordered pair for that point. So notice I'm going to the right 4 and down 4. So this would be the point 4, negative 4. So that's what I'm going to put over here for my vertex, 4, negative 4. And then I identify, do I have a maximum value or do I have a minimum value? So I look, is my vertex the highest point or the lowest point? Here it's the lowest point on the graph, so that means I have a minimum. And my minimum value is y equals negative 4. Okay. Then I look for my axis of symmetry. My axis of symmetry, remember, is the line that cuts the parabola in half. So if I write it on here, it would be this line that goes straight through my vertex, which on this graph would be the line x equals 4. Now, because this is a line, if you just put 4, it's going to be incorrect. You have to actually write out x equals 4, okay, so that it is a line and not just a number. And then the last thing I want to identify, excuse me, are my intercepts. So notice I have 2 x-intercepts here and here, and I have 1 y-intercept. Always write your intercepts as ordered pairs. So that means that my y-intercept, excuse me, is the point 0, 3, and my x, oops, and my x-intercepts, I have 2 of them. I have the point 1, 0, and then it crosses at 7, so 7, 0. Okay. So identify the vertex, identify the axis of symmetry, whether or not we have a maximum or a minimum, tell me that value, and then identify the intercepts. Okay. So we're going to identify those same 4 things, but on this next one it's not graphed for us. So we have to find the x and y intercepts and then graph it and identify all this. Okay, so let's go ahead and look at the next one. Given the function, identify the same 4 things as we did in the last one. First thing being the vertex. Okay, notice this one's already written in vertex form. So if I look here at this number and this number, that gives me my vertex. That tells me that my vertex is going to be change the x value, remember that would be negative 2, and keep the k value the same, or my constant the same. So that means my vertex is going to be at negative 2, 9. So I go backwards 2, and I go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my vertex. And then I can always look over here and see, because of this leading coefficient, which right now is negative, that tells me that my parabola is going to open down. So notice if from my vertex this parabola is going to go this way, then I should have x-intercepts because it's going to go down and cross the x-axis. So let's go ahead and get our intercepts. Excuse me. To find my x-intercepts, remember we set y equal to 0, and here we have a function, so I'm going to say set f of x equal to 0. So I have 0 is equal to negative quantity x plus 2 squared plus 9, and then I'm going to move that quantity to the other side since it's negative. So I do that by adding. When I add the quantity x plus 2 squared to both sides, I end up with quantity x plus 2 squared equals 9. And then I can get rid of that squared quantity by taking the square root. Remember, when you take the square root, you have to remember your plus or minus. Okay. Which leaves me with x plus 2 equals plus or minus 3, and then I move my 2 to the other side. So I have x is equal to negative 2 plus or minus 3. So when I work this out, if I do negative 2 plus 3, that gives me a positive 1, and remember we're doing intercepts, so I'm going to go ahead and write them as ordered pairs. And when I do negative 2 minus 3, that gives me a negative 5. So that means my graph crosses at positive 1 and also at negative 5. Okay. Now this is actually enough points to give us a good parabola, but since our homework will ask us for the y-intercept, I'm going to go ahead and find it as well. So to find the y-intercept, this time I set x equal to 0. When I set x equal to 0, I get y, or f of x, whichever one you use. Y is equal to negative the quantity 0 plus 2 squared plus 9. Okay. 0 plus 2 is 2, which when I square 2, that's going to give me a 4. There's a negative weighting out front. Negative 4 plus 9 leaves me with 5, which means that my y-intercept is 0, 5. Alright, so now I can clearly see my parabola, so I'm going to go ahead and draw my parabola. Okay, so I have my picture, and then I'm going to identify all the things they asked me for. Okay, the first thing they asked me for was my vertex. Remember, my vertex we found to be negative 2, 9. And then it asked me, do I have a maximum or minimum? Here, my parabola is opening down, so I have a maximum value. And my maximum value, remember, is the y value, the highest y value, which here is y equals 9. And then it asked me for my axis of symmetry, which notice if I were to draw this down, this is just the line x equals negative 2. So that means my axis of symmetry is x equals negative 2, or you can just pull that from your vertex. Make sure you write it as a line. And then I write all my intercepts. So my y-intercept was the point 0, 5, and my x-intercept was the point 1, 0, and negative 5, 0. Okay, now there is a worksheet assignment that goes with this section, and it's going to ask you for all of these things. So make sure you write all of your answers in one spot and box it in, or that you circle and highlight your answers wherever you get them. Okay, because it's going to ask you to graph it and to identify all these things. I'm not going to search through your work trying to figure out where all your answers are. So clearly box them in, clearly highlight them, something of that sort. If I can't see it, obviously, I'm just going to count off. Okay, all right, let's look at another one. Now, actually, here, let me just say this. Notice this one was in vertex form. When it's in vertex form, it's kind of easy because all we have to do is identify our vertex by looking at the function, and we can see if it opens up or down. And then we find our intercepts. Intercepts we've done before. Okay, now they're not always given to us in vertex form, which is what we have to talk about next. Sometimes they give us functions and equations that are written in standard form. Okay, to get something from standard form into vertex form, we have to use completing the square. Okay, one thing I want to super duper highlight here is that factoring doesn't produce the correct format. Meaning, even if I give you a quadratic that is factorable, if you factor it, that does not help us. It doesn't tell us anything. What we're looking for is what is our vertex? What is that highest or lowest point on our graph? Factoring does not help us find that. So don't do the factoring step, okay? We don't care about factoring. We're just looking for the vertex. Once we have it in vertex form, then we can work it like the last one we just did. So here's our steps for completing the square. Remember, some of these are written as functions. So if it helps, I usually replace the f of x with a y just so I don't get confused. So I put that here as number 1. Then our second step, again, we move our constant to the other side of the equation. Okay, and then we divide off the leading coefficient. If there's anything other than a 1, in order for completing the square to work, the coefficient has to be a 1, the leading coefficient. Okay, and then once we have just the x squared term and the x squared term, or sorry, just the x squared and the x term, then we can do completing the square. Okay, once we have our squared quantity, then we just move everything back over and resolve it for y. Okay, so the steps are here for you to reference, but it'll just make more sense if I do an example. So let's just go ahead and look at an example. I'm not going to graph this one or anything like that. I just want to refresh you on completing the square. So the first thing I want to do is replace this f of x with y. So I have y is equal to negative x squared minus 2x plus 3. And then I want to move my constant to the other side. Remember, I don't want the constant on this side. I don't need it. So now I have y minus 3 is equal to negative x squared minus 2x. And I'm going to write over here my steps. Okay, so this one was just to move my constant. The next thing I need to do is I need to make the leading coefficient 1. So notice right now it's negative 1. So to get rid of that negative, I divide it by negative 1. But if I divide one term by negative 1, I have to divide every single term by negative 1. So that gives me negative y plus 3 is equal to x squared plus 2x. Okay? So now I have it in the format that I want so that I can go ahead and complete the square. So notice when I go to complete the square, here I'll write squared instead of putting a square. Complete the square. I look at the coefficient of my x term. So I'm going to take 1/2 of 2, which is 1. Okay, now remember our shortcut. Whenever we take half our middle term, that number, whatever it is what's going to show up inside our squared quantity. So I'm going to go ahead and write that here. So I would have x plus 1 squared using our shortcut that we know to be true. Whenever we take half the middle term, whatever that number is, that's what's inside our squared quantity. Now, on the other side, remember, normally when we take half the middle term, we square it and add it to both sides. So don't forget to add that number squared to the left-hand side here. So I'm going to go ahead and write over here that I'm going to add 1 squared. Okay, and then I'll fill in the rest of my equation. So I have negative y plus 3 plus that 1 squared equals now x plus 1 quantity squared because I used the shortcut on completing the square. Now all I have to do is simplify. Okay, so I get negative y plus 3 plus 1 equals x plus 1 quantity squared. I can combine my 3 and my 1, which gives me negative y plus 4. And remember, we're not actually solving this. It's not set equal to 0. We don't want to take the square root of both sides. All we're trying to do is rewrite this function in vertex form. So now I want to resolve it for y. So I'm going to move my 4 to the other side by subtracting. Okay, so I end up with negative y is equal to x plus 1 quantity squared minus 4. And then the last thing I need to do is get rid of that negative on my y. So I can divide by negative 1. Make sure you do it to every term. Okay, so that leaves me with y is equal to negative quantity x plus 1 squared plus 4. Okay, so now look, it's in vertex form. My original was written in function notation, so that will be my last step, is to go ahead and replace y with f of x. So I have negative quantity x plus 1 squared plus 4. Okay, so notice it's the same steps that we've always done for completing the square. Move the constant, divide off the coefficient, take half the x coefficient, square it, add it to both sides, and then before we solved, here, once we have that squared quantity, then we just move everything back over so it's solved for y. So this is the exact same function that I had before. The only difference is it is now written in vertex form. So just as a little hint, sorry, let me rewrite that box, it's driving me crazy. Once it's in this form, now I can easily see, what my vertex would be. I could go ahead and see that my vertex would be the point negative 1, 4. I could see from this negative that it would open down, and then I could keep working it out. I could find the intercepts and plot it and do all that stuff. I'm not going to do it with this one, we'll do it on the next one, okay? This one was just to refresh us on completing the square. So now we're going to put everything together to do this next example. Okay, so we're going to have to use completing the square to get it in vertex form. Once it's in vertex form, we're going to identify the vertex, find the intercepts, and then we're going to list all these things. The vertex, the maximum min value, the axis of symmetry, the intercepts, and then obviously graph it. Okay, so that's where we're going. So the first thing I need to do is use completing the square to get this in the correct format, which is vertex form. So I'm going to go ahead and write y instead of f of x. So y is equal to 2x squared plus 4x plus 3. Okay, I move my constant to the other side. So I get y minus 3 is equal to 2x squared plus 4x. Okay. Then I need to make my leading coefficient a 1. Here, I'll go ahead and leave notes here. I'm going to say move constant. Leading coefficient has to equal 1. So I'm going to divide off my 2. Make sure you divide it off of every single term. So I end up with y over 2 minus 3 over 2 equals x squared plus 2x. Okay. Now I'm going to go ahead and complete the square. Okay. When I complete the square, I'm going to take half my x term coefficient, so half of 2 gives me 1. By my shortcut, I know that this side is going to factor into x plus 1 quantity squared. But don't forget, you have to take that 1 that's highlighted in yellow, square it, and add it to the other side. So I'm going to go ahead and say plus 1 squared on this side. Okay. So now I have y over 2 minus 3 over 2 plus that 1 squared equals my quantity x plus 1 squared. Now 1 squared we know is 1, and in order to combine that 1 with 3 halves, I need a common denominator. So I'm going to go ahead and say y over 2 minus 3 over 2. I can write 1 as 1 over 1, and then I'm going to get a common denominator, which in this case has to be 2. So I'm going to multiply on top and bottom by 2 so that it has the same denominator. So I have y over 2 minus 3 over 2 plus 2 over 2 equals x plus 1 squared. And now I can combine these. So I get y over 2 minus 1/2 equals x plus 1/2 squared. Okay. And now I can go ahead and solve it for y. I'm going to move my constant term back to the other side by adding 1/2. If I add 1/2 to both sides, that moves this. Let me scroll down just a little bit. So I have y over 2 is equal to quantity x plus 1 squared plus 1/2. And then the last thing I need to do to get rid of that 2, to get y all by itself, is notice I'm doing y divided by 2. So to undo division, I have to multiply. If I multiply this term by 2, I have to multiply every term by 2. Okay? So I end up with, my 2's cancel here, and I just have y is equal to 2 times x plus 1 quantity squared plus 2 times 1/2 is 2 over 2, which is just 1. Okay, so this is my vertex form. So I'm going to go ahead and move up here and write it over here. So I have f of x, I'm going to write as a function since our original was written as a function, 2 times x plus 1 quantity squared plus 1. And I'm going to go ahead and box this in because this is one of my answers, is to write it in vertex form. Okay, now that I have it in vertex form, I need to go ahead and identify my vertex. So I look at the number inside my squared quantity, and I look at my constant, which tells me that my vertex is the point -1, 1. So I'm going to go ahead and plot that point. And then I need to decide if it opens up or down. So I look at the leading coefficient, which here is a 2, which tells me that this parabola opens up. Now, think about this. If this opens up, something like this, is it going to have x-intercepts? It's not, right? Because it's pointing up and it's already above the x-axis. So there's no way that it could loop around and hit my x-axis. So right away you could just go ahead and say no x-intercept. I'm going to show you what would happen if you tried to write an x-intercept, what you would get to know that there's not one. So if we wanted to go ahead and solve for our x-intercept, we would put 0 in for y. So I would have 0 is equal to 2 times x plus 1 squared plus 1. I would move my 1 to the other side, which would make it negative. And then I would divide off my 2. When I divide off my 2, I would get -1/2 is equal to x plus 1 squared. And then I would take the square root. Now here, when I do plus or minus the square root of -1/2, notice what happens is I get, excuse me, I get a negative under the radical. Remember, when you get a negative under a square root, that's an imaginary number. Okay, and we can't graph imaginary numbers, just like we can't spend imaginary dollars, right? If I have 1 million imaginary dollars, I really can't do anything with that. So here, if we have a couple of imaginary x-intercepts, we can't graph them because they're imaginary, they're complex numbers. So I'm just going to go ahead and say no x-intercept, because we end up with imaginary numbers. Now you don't have to go through and solve for that if you can just see, oh, okay, my vertex is above the x-axis and it's pointing up, so there's not going to be any. You can just say none. I just wanted to show you what would happen if you didn't notice that and you tried to work it out. Okay, you should always have a y-intercept though. So let's go ahead and work out the y-intercept. Now, here's something I want to point out. It doesn't matter which way you do it, you'll get the right answer. But when we plug in for our y-intercept, we're going to put 0 in for x. Okay. Normally, I always use this vertex form, but I could use my original. So if I were to put 0 into my vertex form here, I would get 0 plus 1, and then I have to square it, multiply it by 2, and then add 1. Notice if I were to plug 0 in for x in my original, that's a lot easier, right? Because 2 times 0 is 0, plus 4 times 0 is 0, is just positive 3. So when I solve for my my y-intercept, I usually like to plug it into the original because it's easier to solve. It really doesn't matter which way you do it though, you'll still get the same answer. But I'm going to go ahead and just put a note here. I'm going to say plug into original because it's usually easier. So I'm going to say y is equal to, if I plug 0 in for x into my original, I get 2 times 0 squared plus 4 times 0 plus 3. 2 times 0 is 0, plus 4 times 0 is 0, plus 3 just gives me 3, which means my y-intercept is the point 0, 3. So if I go up here, 1, 2, 3. Okay. Now I need one more point on my graph so that I get a good picture. You can use the idea that one half of the parabola always looks like the other half of the parabola. So if I know to go from my vertex over to my y-intercept, I'm going over 1 up 3. I know that there should be another point on the other side that's over 1 up 3. Or I can work it out. Okay. Depending on your knowledge of parabolas, I'm fine with both techniques. So I'm going to go ahead and plug in another point because I know I have half the parabola, but I need the other half of the parabola going in the left direction. So I'm going to pick an x value that's to the left of my vertex. My vertex is -1, 1, so I'm going to pick -2. So over here to the side, I'm just going to pick one more x value. I'm going to pick -2. If I plug -2, and I'm going to plug it into my vertex form, I'll get 2 times -2 plus 1 squared plus 1. Okay, -2 plus 1 is -1, which when I square it is going to make it +1, and 2 times 1 is 2, plus 1 gives me 3. So notice at -2, I'm up at 3. Oops, I graphed that other one at the wrong point. Sorry. My y-intercept, I put one box too high. Y-intercept should be 0, 3. There we go. All right, so now I know what my my parabola looks like. So I just connect my dots. Okay. All right. Whew. So we have our picture. Let's go ahead and identify everything it wanted. So it wanted to know the vertex. My vertex here is the point -1, 1. It wanted to know my max or min value. Here my vertex is the lowest point on my parabola, which means we have a minimum. And my minimum y value is y equals 1. Then I want to know my axis of symmetry, which remember is the line that goes directly through the middle of my parabola, cutting it in half, which here would be x is equal to -1. So I'm going to go ahead and write that in. And then it wants to know all of my intercepts, which here the only intercept I had was the y-intercept. So my y-intercept was 0, 3. I'm going to go ahead and circle all my answers. So make sure on your worksheet you clearly have your vertex form circled and you have all of these 4 things they ask you for circled or highlighted somewhere on your page. Okay. All right, let's look at another one and then I'll let y'all try a couple. Okay, so again, we first need to get it into vertex form. Notice this one is factorable. Factoring is not going to get you anywhere. So I'm going to go ahead and just use our regular vertex form. So I have y is equal to, I'm going to write it with, oops, I don't mean to write it up there, sorry. I'm going to write it with a y instead of f of x. Okay. Now remember, when we do completing the square, the first thing we do is move our constant, which we don't have one, and then we divide off our coefficient. So I'm going to divide off the 2. Make sure you do it to every term. So I have y over 2 is equal to x squared minus 4x. Then I can go ahead and complete the square. I'm going to take half of negative 4, which gives me negative 2. And using my shortcut, I know that's the number that's going to be in my squared quantity. So this side is going to factor into x minus 2 squared. And then on the other side, I'm going to have to go ahead and add negative 2 squared. Okay. I'm going to write in my equation. So now I have y over 2 plus my negative 2 squared equals my squared quantity that I got from completing the square. And now I just simplify. So I have y over 2 plus 4 is equal to the quantity x minus 2 squared. Move my 4 back to the other side. So I have y over 2 is equal to x minus 2 squared minus 4. Because when I move that 4, I do subtraction. And then I need to get rid of that 2. And I get rid of it by multiplying every term by 2. So I end up with y is equal to 2 times the quantity x minus 2 squared minus 8. Okay, so that means my vertex form, I'm going to go ahead and write it back as a function just because my original was written as a function, and box it in so I don't forget. Okay, so now I have my vertex form. Now I need to find my intercepts. Oh, well, let me go ahead and identify my vertex. Might as well, right? So if I look at my constant term and inside my x squared quantity, I can see that my vertex should be the point 2, negative 8. So I'm going to go to the right 2 and down 8. Okay, and then notice this 2 out front tells me that my parabola opens up. Okay, so I know it's opening up, which means it should go up and hit the x-axis. So I should have x and y intercepts. So let's go ahead and solve for those. To find my x-intercept, I put 0 in for y. So I have 0 is equal to, now in this one, it's really either way. You could use your vertex form, or you could use your original to find your x-intercepts, whichever one's easier for you. I'm going to use vertex form just because that's what I usually do, and then I usually use the standard form to find my y-intercept. So I'm going to move my 8 to the other side, so I have 8 is equal to 2 times the quantity x minus 2 squared. Then I'm going to divide off that 2, which will give me 4 is equal to the quantity x minus 2 squared. Then I take the square root, so I get plus or minus the square root of 4 is equal to x minus 2. So that gives me, I'm going to move this 2 to the other side by adding, so I'll get 2 plus or minus 2 is equal to x. So if I do 2 plus 2, that gives me the x-intercept 4, 0. And if I do 2 minus 2, I get 0, 0. So here's an x-intercept, and then there's another one at 4. Okay. Now this is enough to give me a good picture. I do want to go ahead and solve for my y-intercept. To find my y-intercept, I plug 0 in for x, which remember I used my original function to plug back into. So that means y is equal to 2 times 0 squared minus 8 times 0. And then both of these terms just become 0. So notice my y-intercept is 0, 0. Which had you noticed before, when we found our x-intercepts, we ended up finding our y-intercept as well. But if you don't notice it right away, go ahead and solve. So I'm going to go ahead and connect my dots. Okay. So we have our picture, and then I'm going to identify all the answers I was supposed to come up with. So remember my vertex, which here is 2, negative 8. I need to know my max or my min. Here my vertex is my lowest point, so this means I have a minimum value of y equals negative 8. and then I identify my axis of symmetry, which remember is the point that cuts my parabola in half, the line, sorry, rather, point that cuts my parabola in half, which here is the line x equals 2. I'm going to go ahead and write that on. And then they want to know all my intercepts. So that means that my y-intercept is 0, 0, and my x-intercept is 0, 0, and 4, 0. Okay? Make sure your answers are clearly indicated on your worksheet. Okay? All right, there's a couple for y'all to try. I'll give you a minute to do that, and then we'll go over them. Okay? Okay, so let's go over the practice problems. On number 1, it was already in vertex form, so all you had to do was identify the vertex, which here would be -1, -1, and then the leading coefficient of -1 tells us that it opens down, so we find our x and our y-intercepts. Now, our x-intercept, we don't have one because it's below the x-axis and it's pointing down. If you try to solve for it, you get an imaginary number, which we can't graph. So there's no x-intercept. So for our y, we then want to go ahead and plug 0 in for x, which gives us a y-intercept of 0, -2. So that really only gives us 2 points on our graph. Okay, when we only have 2 points on our graph, that doesn't give us a good shape. So I went ahead and plugged in some extra numbers here to give us a good picture. The rule of thumb is as long as you get at least 3 points, that's good enough to make me happy. Okay, and then we need to identify our solutions. So here our vertex was the point -1, -1. Okay, we have a max value of y equals -1. Our axis of symmetry is x equals -1. And our intercepts, we only had a y-intercept, which was the point 0, -2. So I'm going to go ahead and circle that, and then we'll look at the second one. Okay. The second one, we had to do completing the square. So we had to make the leading coefficient 1 and move our constant. Those 2 steps, it doesn't matter which order you do it in. You can move the constant first and then divide off the coefficient, or you can divide off the coefficient and then move the constant. Either way. And then when we complete the square, when we take half of our x term coefficient, that gives us a 1, which we square and add to both sides. Now on the right hand side, we use the shortcut so that we know it factors into x plus 1 quantity squared. Don't forget to add it to your left side. Okay. When we simplify, we should end up with y is equal to negative quantity x plus 1 squared plus 9. So this is our first answer, is just to get it into vertex form. Okay. Once it's in vertex form, then we can go ahead and solve for our x and y intercepts, which here I went ahead and just used vertex form to solve for both of those. Our x-intercept should be -4, 0 and 2, 0. Our y-intercept should be 0, 8. So when I plot all of those points, that gives me enough points to draw my picture. And then I identify the things they wanted me to find. My vertex is -1, 9. My maximum y value is 9. My axis of symmetry, which remember is the point that cuts it right down the middle here, is -1. X equals -1. That was not on the line at all, was it? And then my intercepts, which were -4, 0, 2, 0, and 0, 8. Okay, so that is the end of E2.2. There's a regular MyMathLab assignment, which I will tell you. Several of them are multiple choice. They're identify the graph, okay, and they give you graphs to choose from. However, on an exam, you will need to know how to use completing the square and all that stuff. You won't use process of elimination to just pick the right picture. Okay, so make sure, even if you're able to just narrow it down and guess right, make sure you know the process. Make sure you're working it out on paper, because when you get to your exam and the final, it won't be multiple choice. Okay, there is also a worksheet that goes with this section. The worksheets are located under the course materials tab of your MyMathLab course homepage. and this worksheet will need to be worked out by hand and scanned and emailed to me, or take a picture of it and email it to me, or fax it to me. Okay? If you have any questions, let me know, and good luck.